good morning, my dear students. Welcome to this chemistry digital class. As yesterday's video, I have told you about the introduction of amine, and in the same series, today I'm going to tell you the nomenclature and classification and structure of amine. Okay, so dear students, let's understand what is amine. As you know that in organic chemistry we are talking about the derivatives of carbon, in which the functional group we are talking. So similar way, amine is also one of the organic compound, that is the functional group which can be attached with the alkyl group. So what is amine? Basically, amines constitute one of the most important class of organic compound. In nature they occur among vitamin, if I will write, they occur among vitamin, proteins or hormones. Similarly, synthetically, the amine include drugs, polymers, then I can say dye stuff, etc. Then biologically, it is present in some of the enzyme, that adenylene or ephedrine, if I will say. So it is used to increase blood pressure also. On the other hand side, some of the anesthetic medicine, just for anesthesia, antihistamine, these are used. So in our daily life, the amine is very important, and if we will see from where the amine derives, it is the derivatives of ammonia. It means that it is the derivatives of ammonia, mean when ammonia will change, it will convert into amine by obtaining or replacing 1, 2 or 3 hydrogen atom by alkyl or aryl group. For example, this is ammonia, tetrahedral structure, one side one lone pair, 3 hydrogen is there. When any alkyl group will attach to ammonia, then 1 hydrogen will be replaced by that alkyl group. By replacing that alkyl group, the ammonia will convert into amine. Okay, so now basically if we will talk about classification, that is very simple, very simplest classification. Amine are classified into primary, secondary and tertiary. It is on the basis of number of alkyl group. When one alkyl group will attach, by replacing one alkyl, by removing one hydrogen, the NH3 will convert into RNH2, which is shown here also. Then further, when one alkyl will move, then one more hydrogen will replace, then two alkyl is there, that is secondary. When further it will be there, then 3 alkyl is there, then it is tertiary. So in this way, in classification, amine is classified into primary, secondary and tertiary. If now we will talk about the structure, which is very important, ammonia structure. See, structure of ammonia is this. We have studied this. Structure of ammonia is tetrahedral. Similar way, structure of trimethylamine is pyramidal in shape. Okay, it is trivalent. Trivalent mean all 3 side is there, which is carrying an unshared pair of electron on the top, which is called lone pair. 1 lone pair, 3 bond pair. It means that hybridization of N is sp3, as it has tetrahedral. The electronic configuration of nitrogen is 1s2, 2s2, 2px1, 2py1, 2pz1, as N have electronic number 7. Here 1 2s orbital and 3p 2p orbital hybridized to form 4 sp3 hybridization orbital, in which 3 bond pair and 1 lone pair of electron is there. Now bond angle is less than 109.5 degree, which is 108. So this is all about structure. If we will talk about nomenclature, in nomenclature basically there are some rules and steps to follow while naming the amine. That is, first, in common system, an aliphatic amine is named by adding suffix amine. The common name is by adding suffix amine, which is used to the name of alkyl group which is attached to the nitrogen atom. So that the name is called methylamine. Methyl alkyl amine. Similar way, for IUPAC, the suffix amine is used, then it is alkane amine, like methane amine, ethane amine. In secondary and tertiary amine, when two or more group are the same, the prefix di or tri will be used. Like if I'll say, then it is 1, 2, 3. Triamine, trimethylamine is the name. If more than one amino group is present, then different position, then the assigning number and their position is specified by taking the number. Suppose ethane 1 to diamine. In aromatic, the aniline is the in aromatic, the aniline is the compound of benzene plus NH2. It means that if aryl group is there, that is aniline, and it is very important. Similar way, one more compound is there, that is NnCl negative, that is diazonium salt. So these are the name and a few example I'm giving you. I will share the photograph of nomenclature that you will do. Now the most important, that is the preparation of amine. How amine we need to prepare. So you can see in all the reaction first. Amine has prepared. Let me make it with the pen. Amine has prepared. Amine has prepared. Amine has prepared. Amine is prepared. Amine is prepared. And amine is prepared. Okay. So in preparation, always product side that will be kept, which is we are preparing. Okay. So first, there are 5 methods. With the help of these 5 methods, we can prepare amine. First is by reduction of nitro. Reduction mean addition of hydrogen. Nitro mean nitro group, nitrogen dioxide. So both aliphatic and aromatic primary amine, it can be prepared by the reduction of nitro compound, either catalytically with H2 hydrogen in the presence of nickel and platinum, or platinum, or chemically with active metal in acidic metal. Just for example, nitromethane is reacting with 3 hydrogen in the presence of nickel, platinum and ethanol. It will give us methylamine. Methylamine is a amine. Similar way, benzene, nitrobenzene, we can say, will convert into aniline. Second is reduction of nitrile. Again, reduction is there, so we are adding H2. Nitrile formula is C triple bond N. So reduction of nitrile with lithium aluminum hydride or catalytic hydrogenation present, it produces the primary amine. This method is used to prepare amine containing 1 carbon atom and more than the starting amine. So simply nitrile will convert into amine by using nickel lithium aluminum hydride. These are the most important catalysts, dear students, that you need to keep in your mind. Reduction of amide, very simple. Here also lithium aluminum hydride, ether, H2O will convert the I can say the acetylamide into amine. Next is Hopman bromide reaction. This is very important. Hopman bromide reduction is asked many times in exam, both the Gabriel phthalimide, as word is written bromamide, so it means the bromine is there, degradation mean removal. So here acetylamide is in this reaction used to prepare amine containing 1 carbon less than the starting amide. This method was developed by preparation of primary amine by reacting amide with bromine or chlorine in NaOH. So bromine will react with NaOH and it will convert into RNH2, Na2CO3, NaBr plus 2H2O. That is called Hopman bromide degradation. Gabriel phthalimide synthesis, phthalimide. This is phthalimide, and Gabriel has given the phthalimide will react with KOH alcohol. It will convert into potassium phthalimide. From there, again it will react with haloalkane. It will convert to N-alkyl phthalimide. From there, NaOH, it will change into sodium phthalimide plus amine. Okay, and we need this thing. So this is all about preparation. Now tomorrow's video I will tell you about the properties. But dear students, once again, before going to end this class, I'm going to remind you about the worksheet that about the assignment that has given to you. Hope so you have finished. Only today's day, tomorrow's day, you have do complete the assignment, and before Monday 9 o'clock you need to submit it on my WhatsApp. So hope so today's video is helpful to you, and it is the basic introduction to nomenclature, classification and preparation of amine, in which this is the most important that you need to learn, preparation of amine. So till my next video, take care of yourself, stay home, stay safe, and note down the notes and keep on doing self-study. Thank you. Have a nice day.
Amines. Amines are formed by the replacement of 1, 2, or 3 hydrogens of ammonia by alkyl or aryl groups. Structure of amines. The bonding in alkyl amines is similar to the bonding in ammonia. The nitrogen atom is sp3 hybridized with the 3 substituents occupying 3 corners of a regular tetrahedron and the lone pair of electrons occupying the 4th corner. The C-N-C bond angle is very close to 109 degree. For example, 108 degree in trimethylamine.
In this online lecture, we're going to talk about how to name amines. And an amine has this functional group right here. Sometimes it's NH2, sometimes it's NH, or sometimes it's just N. We'll look at those examples in a few minutes. And one thing I'd like to mention here is that before you watch this lecture, make sure you've watched the nomenclature of ethers and alcohols. That'll make this a lot easier. Simply because we use some of the methods that we used in ethers and alcohols to name amines. So let's start here with step 1. We need to find our longest chain that contains the carbon that has the amine. That's kind of like with alcohols, remember? So that means this is the longest chain right here. And since that's 4 carbons, our parent name so far is butene, but since this is an amine, we put it in the parent name. So this is now called butenamine. This is also similar to alcohols in the sense that that's how much priority amines have. They actually go into the parent name of the molecule. So that brings us to step 2 here. The correct numbering, in this case, we want to do from right to left. Again, just like we saw in alcohols, we want the amine to be on the lowest number carbon as possible. That brings us to step 3 here. This is the point where we kind of treat the NH2 as a substituent. Here he is, but we don't label him as a substituent. Instead, we work our way to step 4, and all we have to do to finish this off is put a 1 in the name here. So this is 1-butenamine. And again, think about what the name is telling you about this structure. Buten means 4 carbons, amine means there's an amine group, and 1 is telling us on which carbon of the alkane is the amine on. However, let's look at some sample problems to see some of the nuances of naming amines. Now careful, if you're on your orgo test and they give you this molecule and they ask you to name it, the first thing I'd like you to do is kind of expand it out here. This really is this right here. So let's look at this structure instead. This brings some clarity to the molecule and helps us better name it. So for step 1 here, notice I have carbon groups on both sides of the nitrogen, kind of like with the ether when you had alkyl groups on either side of the oxygen. And remember, with ethers, we pick the carbon chain that's longer. And in this case, you got a 3 carbon chain on the left, a 1 carbon chain on the right of this nitrogen. So that means this is the longer chain, which means he makes up part of the parent name of this molecule. He's 3 carbons long, so the parent name here is propenamine. That brings us to step 2 here. We want to get the correct numbering here, and of course in this case we'd want to number from right to left so that the nitrogen could be on the lowest number carbon here, in this case carbon 1. That now brings us to step 3. Let's circle and label. Technically the only real substituent here is this methyl right here. So we're now ready for step 4. And watch what happens here. Here's what we're learning. In order to call out that methyl substituent, notice he's connected to the nitrogen. He's not connected to any of the numbered carbons in the main chain. So the way we express this in amines is we say N-methyl. Think about what that means. It's saying on the nitrogen there is a methyl, and that's exactly what we have. And to finish this name off, we need to put a 1 here. So the name of this molecule is N-methyl-1-propanamine. And like we've done before, take a few minutes and match the name with the structure. Think about it. If you saw this name, you would think propen, you would think 3 carbons long, you would see amine, you would think it's some kind of amine, and the 1 is telling you that the amine is on the 1 carbon of the propen. Then you would direct your attention to the N-methyl. That would tell you to put a methyl on the nitrogen. Now, just to make sure you got this, let's change up this example a little bit. Let's put 2 methyls here on the nitrogen instead of 1. How would that change things? Well, just use the system here. We would call this molecule NN-dimethyl-1-propenamine. Notice what we're doing here. Instead of calling out the numbers that these substituents are connected to, we're using the N instead of a number. So that's why, remember, if there's 2 methyls, you have to call out each one by saying N, N. And again, because there's 2, that's what the di is for in the dimethyl. So let's look at another example here, and let's throw a halogen in and see what happens. Step 1. Remember, the amine, just like the alcohol, has priority here. So you want to find the longest carbon chain that has the amine, and that would be this carbon chain right here. We got 4 carbons in the box, so parent name is butenamine. Now, for step 2, the way we want to number the carbons here, of course, is from right to left, so we can get the amine on carbon 1 and the chlorine on carbon 3 and have nice low substituent numbers. Which brings us to step 3, circling and labeling our substituents. Notice we have the chlorine right here, but we also have this methyl right here. So that makes us ready for step 4 now. Let's place this all together. Notice chloro comes before methyl in the alphabet, so we should put the chloro first. He's on carbon 3, so we have 3-chloro-N-methyl-1-butenamine. Take a few seconds again and connect the name of this molecule to its actual structure.
Preparation of amines. Reduction of nitro compounds. The reduction of nitrobenzene in acidic or neutral solution results in the formation of aniline. Nitrobenzene is reduced to aniline by passing hydrogen gas in the presence of finely divided palladium. Ammonolysis of alkyl halides. The process of cleavage of the CX bond by ammonia molecule is called as ammonolysis. If alkyl halide is in excess, the primary amine formed further reacts with alkyl halide to form secondary amine, tertiary amine, and finally quaternary ammonium salt. The reactivity of the various halides decreases in the following order, that is Ri followed by RBr followed by RCl. Preparation of amines. Reduction of nitriles. The reduction of alkyl nitriles with lithium aluminium hydride or catalytic hydrogenation form primary amines. Reduction of amides. Amides are reduced to corresponding amines by lithium aluminium hydride. Preparation of amines. Gabriel phthalimide synthesis. In this process, phthalimide is reacted with alcoholic KOH to get potassium phthalimide, which reacts with alkyl halide to form N-alkyl phthalimide, which on basic hydrolysis gives primary amine and phthalic acid. Phthalimide reacts with alcoholic KOH to get potassium phthalimide, which reacts with bromoethane to form N-ethyl phthalimide, which on basic hydrolysis gives ethylamine and phthalic acid. Hofmann-bromamide degradation reaction. When a primary acid amide is heated with an aqueous or ethanolic solution of NaOH or KOH and bromine, it gives a primary amine with 1 carbon atom less.